Hi everyone, I'm Tian. Here I'll introduce our work Dense-Localizing audio-visual events in untrimmed videos, a large-scale benchmark and baseline. In a video, an audio-visual event occurs only when it's both audible and visible at the same time. Previous AVE task aims to localize only a single audio-visual event in a trimmed short video clip. However, in real-life scenarios, videos always long and untrimmed, there are often multiple events from different categories in each video and they might be very short or long and occur simultaneously. Therefore, in this work, we built a large-scale UNAV100 dataset as the first audio-visual benchmark based on untrimmed videos, and we shift previous AVE tasks to a more realistic setup and propose a new framework. Our model achieves superior performance over related sort method for untrimmed videos. Here, I will first introduce our proposed UNAV100 dataset in detail. Different from previous AV dataset, our UNAV100 dataset is based on long and untrimmed videos. It covers a wide range of domains including human activities, music performances, and sounds of animals, vehicles, tours, nature, and so on. There are more than 30,000 audio-visual events from 100 event categories distributed in over 10,000 videos for over 126 hours. As the first audio-visual dataset built on untrimmed videos, UNAV100 is quite challenging for many reasons. Firstly, around 60% of videos contain more than one audio-visual event, and each video contains 2.8 audio-visual events on average. Second, the length of audio-visual event varies greatly from 0.2 seconds to 1 minute. Short events are often difficult to detect, but it aligns with real-life scenes. Besides, there are rich temporal dependencies among events occurring in a video. For example, people often clap when cheering, and ring is usually with thunder. Related events usually occur simultaneously or consecutively in a video. Such dependencies are very similar to real-life intuition and reflect human behavior. Compared with existing related audio-visual datasets, our dataset offers temporal boundary annotations for all audio-visual events occurring in videos, and it is the only dataset based on untrimmed long videos and has multiple audio-visual events in one video. Here is a video example with temporal annotations. Since existing AVE methods formulate the task as a single label segment-level classification problem and can only identify one audio-visual event for each segment in a trimmed video, they can't be applied in the complex real-life sense mentioned before. Therefore, we shift the AVE task to a more realistic setup of dense-localizing audio-visual events, formulate it as a joint classification and regression problem. We propose a new framework to flexibly recognize all audio-visual events in an untrimmed video and meanwhile regress their temporal boundaries in a single pass. As is shown, video and audio feature vectors are first extracted from pre-trained models. Then, the feature sequences input a cross-model pyramid transformer encoder to integrate audio-visual signals at multiple temporal scales. It helps a model to capture audio-visual events with various duration. After that, we concatenate the enhanced audio and visual features at the same pyramid level, getting a cross-model feature pyramid. Then we expand the C-prime dimension for each cross-model feature sequence in the feature pyramid, and implicitly capture simultaneous and consecutive temporal dependencies among audio-video events in a video using two separate branches. Then the output of the two branches are simply merged to enable the model to capture both types of dependencies. Next, a decoder consisting of a classification hand and a regression hand is applied to decode the enhanced feature pyramid into prediction results in a single pass. Here, the regression hand is designed to be class-aware. It allows the model to regress temporal boundaries for the overlapping events with different categories. Finally, the classification and regression laws are combined to train the model in an end-to-end manner. We evaluate our model on the test set of our proposed UNAV100 dataset. We compare our model with recent state-of-the-art temporal action localization methods because previous AVE methods are not suitable for untrimmed videos. As we can see, integrate audio and visual modalities can significantly improve performance, which indicates both audio and visual modalities are equally crucial for the task. Besides, our proposed model surpasses the compared TAL methods by a large margin, even though they also benefit greatly from multimodal input. We also explore the cross-model fusion strategies and the design of the cross-model feature pyramid in the framework. The results show that the cross-model fusion at multiple temporal resolution is essential for our model. Besides, experiments also demonstrate the effectiveness of dependence modeling and class-aware regression hand in our model. Here is a visualization result of our model variants that utilize different modalities as input. We can observe that the model using both modalities can localize audio-visual events more correctly, even though some events occur simultaneously or have short duration. Thank you for your listening. Our dataset and code are released. You can visit our project page by scanning this QR code.